In this example, we're going to solve this system of linear equations by graphing. The first equation you'll notice is in point-slope form. So the first thing we can do is grab the point from the equation. So the point will function as a place to start on the graph, and then we can use the slope to make more points, and ultimately go ahead and use a straight edge to draw the line through all those collinear points. So our starting point is going to be an x and a y, so it's a -6, -4, because recall from point-slope form, this is a minus in the equation, so we're going to change the sign. So the x value is -6, and the y value is -4, and the slope we're going to use is 1/3. For the second line, I'll notice that the equation is in standard form, so I need to isolate this y. So I'm going to go ahead and subtract x from both sides, and I'll have -y equals -x plus 4, and then I can divide every single term by a -1, and that will cause my y to be positive. Will also cause my slope to be positive, and then my y-intercept to be a -4. So the equation here, I have a y-intercept of -4, so that ordered pair will be 0, -4, and then my slope is going to be, it looks like a 1. Okay, so let's go ahead and slide it over a little bit, and let's plot all of this stuff and draw our lines. So our starting point is -6, -4, so -6, -4 right down here. And we're going to use a slope of positive 1/3 then to make more points. So up 1/3, up 1/3, up 1/3, and one more time. So let's grab a straight edge and go ahead and draw the line for that. Okay, so there's our first line graphed. So our second line, we know had a starting point at 0, -4, so right down here, and it had a slope of 1, or 1/1 if you want to look at it that way. So it's up 1/1, up 1/1, here's a shared point right there, up 1/1, and so on. So I'm going to grab the straight edge here, and go ahead and draw this line. So we have both lines graphed now, and we're going to see that there is this common point, this point of intersection between these two lines. This point, again, represents the only ordered pair that will satisfy both equations. So that ordered pair is going to be the solution. That's what I'm looking for here. So the solution then is going to be 3, -1. I'm going to go ahead and box that ordered pair. This is the solution of the original system. And if we want to, we can classify this system then as consistent and independent, since it has a single solution which represents this single point of intersection.